This lecture is brought to you by Advanced Mathematical Research Group. Okay, now we're gonna analyze the rise of the liquid through a capillary tube. Now the rise of the liquid through the capillary tube is because of the surface tension S. Okay, now we can see that if I am putting a tube in a liquid, then the liquid is rising to the height h. Okay, now because of the pull of the surface, because the pull of the liquid by the surface, what we are seeing that to the left and the right at the contact point there is a rise of the liquid, and this rise is convex upward, and it is showing that the surface tension of the liquid is smaller and the contact angle theta is less than 90 degree. So it must be convex upward. Okay, now we have to analyze this very particular system whose height is h and the radius is r. Now what are the forces that are acting on this very particular system? So I will consider this very particular volume of height h having cross-sectional area delta of S is equal to pi r square as a system. Now we can see that there is a tangential force, a force that is tangential to the peripheral of the fluid, and that tangential force should be equal to S times d of L. Now since the contact angle is theta, this S times d of L will have two components, S times L times cosine theta, that will be perpendicular to the surface, and other will be S times d of L times sine of theta. Now if S times L times d of L times sine of theta will be integrated through all the surface of the hemisphere, then we will see that S times d of L times sine theta is to the left, and also S times d of L sine theta is also to the right. So these are symmetrical about y-axis, and thus its summation through all these peripheral will cancel out. So what are the forces that are remaining? There is only S times d of L times cosine theta. S times d of L times cosine theta. Now S times d of L times cosine theta can also be written as S times d of L times cosine theta. Now d of L times cosine theta, so that can also be written as projection of the differential length along y-axis. So we can write, now this is a differential force along y-axis. Now what will be the all force? What will be the all force that will be working along the y direction when we will sum it through the peripheral of the hemisphere? So now we are going to integrate it to the peripheral of the interface. So we have to integrate what? We have to integrate dl. Okay, we have to integrate dl. So integration of d of L should be equal to 2 pi r. So S times cosine theta is a constant. S times cosine theta is a constant, and integral of d of L should be equal to 2 pi r along all the circumference of the hemisphere. Okay, so finally we are getting the force, resultant force along y-axis as S times 2 pi r times cosine theta. Now the question is, what are the other forces that are working on this system? Now since this system is open to the atmosphere, now since this very particular system is open to the atmosphere, what we are going to do? We are going to consider the atmospheric pressure that is working on the fluid, and that should be equal to P naught times delta of S, that will act downward. Now we can say this the liquid which is outside this surface is open to the atmosphere and thus acted by atmospheric pressure P naught, and we know that the pressure along a horizontal line is same. So atmospheric pressure outside must be equal to atmospheric pressure inside. So we can say that the force that is working at the bottom, we can say that the force that is working to the bottom upward because of the atmospheric pressure should be equal to P naught times delta of S. Now we can say that since delta of S is constant and atmospheric pressure is also constant, that is working downward, the force F1 that is working upward at the bottom, that is equal to P naught delta of S, and the force that is working top in the vertically downward direction is P naught times delta of S. So at the top the force is having downward direction, P naught times delta of S, and at the bottom it is having upward direction, having same magnitude, and hence they are going to cancel out. So we can say that the force due to atmospheric pressure vertically upward will be cancelled by the force due to atmospheric pressure vertically at the downward position vertically upward. So at the top the force is downward and at the bottom it is upward, so these are going to cancel out. So what are the resultant forces that is working on the system? Now other forces that we are going to consider is the weight of the fluid. What is the weight of the fluid that is contained in a cylinder? What is a weight of the fluid that is contained in the cylinder having height h and cross-sectional area delta of S is equal to pi r square? So we can say that the weight of the fluid should be equal to density times change in volume. What is equal to volume? Volume should be equal to height multiplied by area of cross-section, and then that is equal to weight, and this weight is required to be multiplied by g. So mg is the force downward. Now important thing is that we are not considering the weight of the fluid that is in the meniscus. We will neglect it. Later on we require to do a correction and we will add that very particular weight of the fluid. And what is the weight of that fluid? That will be equal to volume of that fluid multiplied by density multiplied by g. What will be the volume of that fluid? That is equal to volume of the cylinder, whose base area is pi r square and height is r, minus of the volume of the sphere, half of the sphere, that is hemisphere, that is equal to 1 upon 2 times 4 upon 3 pi r cube. Okay, so but we will not do the correction right now. That is a homework for you to do the correction. So we can say weight should be equal to mass times acceleration due to gravity, mg. So we can say that weight should be equal to what is equal to mass? Mass is equal to density multiplied by volume. And what is my density? Density is equal to rho times volume, h times delta of S, where delta of S is equal to pi r square. This weight will act downward. So now we will consider, is there any other forces that are acting on the system other than this weight and the force due to surface tension and the atmospheric pressure? No. So the force due to atmospheric pressure is cancelling out. So we are remaining with two forces. One is the force upward due to surface tension, that is equal to cosine theta times 2 pi r times surface tension. And other is the force because of the weight that is just working downward. And what is that force? That force is equal to density multiplied by volume, h times delta of S times g, because density multiplied by volume will give us mass and mass times g will give us the weight. Now applying summation of all the forces along y-axis is equal to mass times acceleration along y-axis is equal to 0, because the system is in rest, fluid is in rest, and hence its net acceleration should be equal to 0. So we can say that the force upward 2 pi r surface tension times cos theta minus of the weight downward, that is equal to mg, must be equal to 0. And finally we will come to the equation 2 pi r s cosine theta must be equal to rho g times delta of S times g. Now the correction terms rho times d of v times g will be neglected. So from here we can say h must be equal to 2 pi r s cosine theta upon rho delta of sg. So we are going to write that term. So we can say that h should be equal to 2 pi r times s times cosine theta upon rho times delta of sg. We know that delta of S is nothing but the area of the cylinder. What is the cross-sectional area of cylinder? That is pi r square. So substitute it by pi r square, delta of S by pi r square. So we can say that r and r will cancel out, pi and cancel out. So h must be equal to 2 times surface tension times cosine theta upon rho times rg. Now we again require, there is a height rise. Now if we will consider the weight of the fluid that is contained inside that is the meniscus. That is a small, you can see the small layer of the liquid that is there. So what will be the volume of that liquid? That is equal to the volume of the cylinder having area pi r square, height is equal to r, minus of the volume of the hemisphere. So that should be equal to what? So that volume of the meniscus should be equal to pi r square multiplied by r, that is equal to the volume of the cylinder, minus of the volume of the hemisphere, that is equal to half of 4/3 times pi r cube. That is that volume. Now that volume multiplied by density will give us the mass, and mass multiplied by g will give us the weight. So we require to do this correction in the final formula. So we will add rho times d of v times g, that is the weight of the meniscus, in the final equation, and you know what is this differential volume. What is this differential volume? That is coming out to be pi r square r minus of half of 4/3 times pi r cube. So if you want that correction, you can put, and then you can calculate the final height. Now in the next lecture, we will come to all the advanced mathematical concepts like divergence theorem, curl theorem. We will also deal with fast Fourier transform, FFT, and the Fourier transform. Now we can implement Fourier transform in a computer as a fast Fourier transform. So what we are going to do, first we are going to analyze the complex, the nth root of the complex number, and then we will relate nth root of complex number with Fourier transform. Okay, we will relate that to Fourier transform, and then we will tell you the ways how to calculate the fast Fourier transform. So to subscribe, to watch fast Fourier transform, subscribe to our lecture, or to continue the lecture in physics, you can again subscribe to this very particular channel. This lecture is brought to you by Advanced Mathematical Research. Okay, so you can subscribe, you can watch, also you can make a common discussion platform where we gonna answer your queries. Okay, so in the next session, so we are having a complete package of physics, chemistry, mathematics, and biology, where we will provide you the correlation between mathematics and physics and chemistry, and then we will relate chemistry completely with your biology. For example, in chemistry we will prove Gibbs free energy change. We will prove Gibbs free energy change in thermodynamics. Also we will consider that in redox reaction, and then we will relate redox reaction to biochemistry. So it will really enhance your concept, and will make your views clear that were never before. So to really understand the matter to the depth and be able to correlate the subject to its zenith, subscribe to our lecture. Till that, thank you very much. Thank you for watching this lecture.